Hi students, welcome to Sri Ramanuja Vidya Mandir, a temple for learning. Children, in previous lecture, the discussion was done on what is inertia. A complete detailed discussion was done on inertia, children. What is inertia? Inertia is a property of a body, an inherent property of a body, children. It is inbuilt. Okay, we are not assembling that property. That is inbuilt quality for any body which is containing some mass. What it will do, children? What that property will do? It will make the body to resist the change. The property of a body, it itself make the particular body to act opposite to the change in its state. Change in the sense, children, whether it may be rest to motion or motion to rest or a change in the direction of the body, whatever. Whenever there is a chance for changing its state, the body is not willing to accept it. It is resisting that change. Okay, children? That is created due to the mass which is present in that particular body. The mass in that particular body not accepting the change. It is resisting the change. Okay, so due to that reason, objects which are having a larger mass requires a larger force in order to make it change from rest to motion or motion to rest. Okay, children? So, the inertia is a property which depends on what, children? Directly dependency on mass. What, children? Inertia has direct dependency on mass. And what is types, children? Inertia of rest, inertia of motion, and inertia of direction. Inertia of rest in the sense, children, simply the body is not willing to change its state from rest to motion. That is what? Inertia of rest. Next, inertia of motion. What is inertia of motion, children? It is a property of a body which is resisting the change in state of motion. It is not willing the body to come into the rest condition. Next, inertia of direction. Resisting the change in direction. That's it. Okay, children? Maybe the things are simple but very, very important to understand. The Newton's laws of motion effectively. Okay, children? Next. After inertia, the important thing is, children, momentum. We made discussion on momentum also. What is momentum, children? It is a quantity. It is a quantity of motion. Simple, children. Quantity of motion. How we can define, how we can write formula for momentum, children? Momentum. How we can write? Momentum, children, see here, there are two types. Momentum is not one kind, children. It is of two types. Okay. So, one is linear momentum, children. Next, angular momentum. Children, see here, linear momentum we denote with P. What is that, children? The alphabet P. Angular momentum we use it to denote with L. By what, children? L. Okay. So, children, once observe, if a body is moving in, see, children, this is the path. On this path, let us consider a ball which is rolling. Okay. It is moving in a straight line. The ball moving along a straight line. Okay. Means it is a linear motion, children. Linear. Okay, either like this, or if you consider example rocket, children, rocket, how it will move? Vertically upwards. Initially while it is launched, how it will go, children? In vertical direction. Okay, these two comes under what, children? Linear motion. Okay, the body is moving in a linear motion along a straight line. If a body is in motion, when we check its path, if the path is a straight line, then it is what, children? Linear motion. Okay. So children, once observe. Here let us consider the mass of this ball, mass m, and here let us consider the mass m only, children. Okay, and velocity. Velocity, let us consider it is moving with v. Okay, children. Here also it is moving with, let us consider v, children. The rocket which is moving vertically up, it is moving with velocity v. Then in these two cases, in the first case and in the second case, the bodies are moving along a straight line, children. Either x-axis complete horizontal or y-axis complete vertical. Okay, this one comes under linear motion. So here the momentum will be what, children? Momentum P is equal to m into v. Okay, children. For these two cases, same thing we will do. M into mass into linear velocity. Which velocity, children? This one? Linear. Linear velocity. Okay. Next. What about angular? Angular in the sense, children, the body is moving in a circular path. That particular object is moving in a circular path. Okay, children? So whenever any body, any object or any particle, when it is moving in a circular path, this will have, that particular body will have angular velocity, children. What it is? Angular velocity, omega. Okay, children. So here we are taking linear velocity, children. Here we consider what? Angular. Okay, angular velocity we will consider. Children, today means for us the topic is regarding what is linear momentum. Okay, children. So let us continue our discussion on further linear momentum. See here, children. Whenever the velocity is initial velocity, we write as u, children. Whenever it is final velocity, if the velocity is what, children? Final. We denote with v. Okay, final velocity v. Children, see here. Whenever in that specific formula, p equal to m into p equal to momentum, p equal to mass m into velocity, in this particular formula, children, suppose if we are replacing this velocity u, okay, the mass is m, children, and this one is p, that is nothing but momentum. Children, see here, this momentum is called initial momentum. Initial momentum. Okay, next. Children, let's if you replace with v, Then the momentum that we obtain is what, children? Simply, if we replace with v, that is final velocity, then the momentum will be what, children? Final momentum. Okay. Final momentum. So children, let us consider here one car there, okay, and the car moving, and the car at this position, children, now. So children, let us consider this one as initial point and this one as final point. Then the momentum whatever it is having at the starting point is called which momentum, children? Initial momentum. At the final, which velocity it is, which momentum it is having, that is called what, children? Final momentum. Okay, initial momentum and final momentum. Means we are taking a time sequence, children, a time interval. Okay, at that moment, at the starting, what amount of momentum it is having, that is called initial momentum, and at the end, which momentum it is having, that is called final momentum. Okay, children, this thing is very, very important. So what I want to say is, whenever the initial velocity is changing, velocity is changing, the momentum also changes, children. Mass remains same. If the mass remains same, if you see, children, that particular car, the car moving in its journey, its mass never change. Mass is constant. Okay, but what will change, children? Velocity will change. Here it is u and here it is v. Okay, so whenever the velocity is changing, when the mass kept constant, obviously what will change, children? Momentum will change. Okay, so children, next thing, see, children, we know about kinetic energy. Kinetic energy. See, children, what is kinetic energy? Kinetic energy. In work power energy chapter, we discussed regarding this kinetic energy. What is kinetic energy? Energy that was possessed by a body due to virtue of its motion. Means a body, when it is in motion, it possesses some energy, children. That energy is nothing but what? Kinetic energy. Kinetic means there will be a movement, there will be a motion. Suppose if it is static, children, we have two terms, static and kinetic. Static in the sense there won't be any motion, there won't be any change in the position. While we are discussing about kinetic, children, there will be change in the position of the body. Obviously that is motion, there will be a motion. So here children, when we are discussing about kinetic energy, what is kinetic energy? Whenever any body, if it is in motion, it possesses some energy, that is kinetic energy. Energy possessed by virtue of its motion. See, children, here let us consider this is a plane and here a ball and the ball moving, children. Okay, as soon as it is moving, it moves with some velocity, no, children? It moves with what? Some velocity. Let us consider v, some velocity v. And the mass of this ball is m. What is its mass, children? M. The mass of ball is m. Okay, children? So, what is formula for kinetic energy, children, at this point? Kinetic energy is equal to half into mv square. Okay, children? So, mass into velocity square, half into mass into velocity square. That is nothing but what? Kinetic energy. Kinetic energy formula. Okay, children? So, see, children, here This ball contains some mass. Okay. What we did, children, in this particular sequence? This is a surface, children. This is surface. On the surface, the ball is rolling. Okay. So we did multiplication of mass into velocity, and still what we did, children? We multiplied with half and v again. Okay. See, children, this one is kinetic energy. What will be momentum, children? What will be momentum? Momentum. P is equal to, what is the formula, children? Momentum P is equal to mass of the ball into velocity of the ball. Okay. So this is what, children? Momentum. Children, here if you observe, there is similarity between these two. There is some similarity between these two, children. Kinetic energy and this momentum. Okay, what it is? See, children, kinetic energy I am replacing with K. Instead of kinetic energy, I am just simply writing K, children. K means kinetic energy. Okay. So kinetic energy is equal to half into mv square. Okay, this is the formula. Now what we will do means just multiply and divide with m. Okay, children, that half mv square, just multiply and divide with m. What we will get, children, further? Half into m into m by m, children. Okay. Here what we got? Half into m by m into v square. Just rearrange those terms. Next what we will get, children? Half into m square. Okay, this mass became now square and velocity square by mass m. Okay, children. So if we observe what we got, m square v square by m. What is m square v square, children? P is equal to mv. Okay. Now squaring on both sides. What we get? P square is equal to m into v whole square. P square equal to m into v whole square. What we get, children? P square is equal to m square v square. Okay, children, once observe. What is the equation we got now? K is equal to half m square v square by m. So instead of m square v square, what we can write, children? Now we got this relation. Instead of m square v square, we can replace with p square. Okay, further what we get, children, from here? Kinetic energy K is equal to p square by 2m. Okay, children, this 2 and m in denominator. Okay, so this is the relation between kinetic energy and momentum. Okay, children, what is the equation we got? K equal to p square by 2m. See, children, this is the equation we got. K equal to p square by 2m. This is one of the relation. Kinetic energy and momentum. Now again I am taking that equation, children. Now from here, what will be p value, children? What will be p square? Send this 2 and m this side, children, and this square also this side. What we get finally? The square become root. Okay. So p is equal to root over 2 k m. This is also another relation we have, children. Okay, two equations we have for getting the relation between kinetic energy and momentum. What it is, children? Relation between kinetic energy and momentum. Okay, what we got, children? K equal to P square by 2m. What is another equation, children? P equal to root over 2km. Okay, these are very, very important, children. We need to use while solving the problems. Okay, children, suppose if kinetic energy of the particle and momentum both are equal. Okay, children, suppose if kinetic energy and momentum both are equal, what will be the velocity, children? See, children, when these two can be equal, we need to equate momentum and kinetic energy. Okay, so here what is formula for momentum, children? M into V, which is equal to half into M into V square. Okay, so from here we can do cancellation. Okay, children, so what we get? Velocity V is equal to 2 meter per second. Okay, children, at which condition momentum and kinetic energy both will equal? At which condition the kinetic energy of the particle and momentum can be equal, children? Whenever the velocity of the body is 2 meter per second. Okay, children, if the body moving with 2 meter per second velocity, then we can simply find either momentum or kinetic energy, children, both will be equal. Okay. See, children, the next one, impulse. Very, very important, children, this one. Impulse. Impulse can also be written as change in momentum. Impulse or change in momentum. Children, previously I written two things, initial momentum and final momentum. Initial momentum means velocity, the momentum of the body at the initial condition, momentum of the body at the final condition. That is momentum, children, change in momentum due to change in velocity. Okay, children. So here, what is impulse? Impulse in physics is a term that is used to describe or quantify the effect of force acting over time to change the momentum of an object. See, children, impulse. What is impulse, children? It is a term for what we indicate, for what it is a term used to describe or quantify the effect of force acting over time. Effect of force acting over time. Okay, children. So, children, here simple thing I will give. I will say here. Impulse is nothing but impulse we use it to denote with I, children. Okay, so I is equal to force into time. Okay, children, impulse I is equal to force into time. Okay, children. So here this impulse, what it will do means it will exert force, children. What it will do is it exert force. Okay, it exert force, but only short period of time. Within a short period of time, see, children, we have a relation between that force and time. Okay, so within short interval of time, let us consider this axis force, children. This one is time. So here, when the force is acting, larger amount of force, children, time is less, but force is what? More. Less time and more force. Okay, children, the effect what we used to get due to this condition is nothing but impulse. Okay, children. So here I will give you an example. Suppose if you are moving on a road, suppose if there is any speed breaker, okay, without decreasing the speed, suddenly if you, whenever there is a speed breaker, what that vehicle should do, children, the driver of that particular vehicle, he should decrease the speed. He or she, whenever that person is particular person driving any vehicle, if any speed breaker is there, they need to decrease the speed. Without decreasing the speed, suddenly if you once imagine you move over the that speed breaker, what will happen? Sudden force will exert on the passengers. Suddenly the passengers will rise to some height. Okay, children, usually that thing will happen whenever there is more force. Okay, more force got created within short span. Taking over the speed breaker hardly takes 2 seconds, children. That's it. 1 or 2 seconds. Very short time. But what will happen, children? The effect is more. Okay, but what is the case? The effect is more. Okay, children, but why I given this one at this moment is, previously I discussed one topic, children, that is change in momentum. Okay, the terms related to the momentum I am explaining at a time. Okay, so here one subject, children, it is the force acting over a time to change the momentum of an object. Why it is what it is doing, children? It is changing the momentum of object. Okay, I will give you an example, children, now. If see, children, a car moving, children, and reach it to some point here. At the starting condition, we have taken some time sequence, children. At the start, which velocity it is having, that is initial velocity, and at the end, what it is having, that is final velocity. Children, even the momentum, initial momentum, children, this one. Okay, next to this one, final momentum, final momentum. Children, here since the velocity is changing from u to v, this momentum also changing now, children, from pf to pi to pf within some certain time. Okay, children, within some certain time, what happened? The momentum of a body is changing from some value to the some initial velocity to final. Initial value to final. Due to what, children? Due to change in velocity from initial to final. Okay, I already mentioned this one, children. I gave you this condition. The momentum of a body at the initial condition is initial momentum. At the final, it is final momentum. So there is change in velocity, children. So there will be change in momentum also. The change in momentum is nothing but Pf minus Pi. Final momentum minus initial momentum. Okay, children. Final momentum minus initial momentum. That is change in momentum. This one occurs within some certain time interval, children. Within some certain time, what happens? The momentum of the body change from one value to other value, from initial to final. Okay. So how much is that change? That change is caused due to what, children? Due to impulse. So children, see here. Here this is the change in momentum. Okay, Pf minus Pi, that is change in momentum. It is caused due to what, children? It is caused in the change in momentum was, we got this change in momentum in one specific time, children. Okay, this was caused due to what? Due to impulse. How it is done, I will explain, children. So before that, let us see what is Newton's second law. Newton's second law states that the acceleration of an object as produced, see children, acceleration of an object as produced by a net force is directly proportional to magnitude of the net force in the same direction and inversely proportional to mass of the object. See children, the acceleration of the object. Here Newton's second law describes about what? It describes about acceleration. So this acceleration is proportional to what, children? Net force, directly proportional to net force, and it is inversely proportional to mass, children. Inversely proportional to what? Mass. Okay. So on a combination, what we can write, children, here? Acceleration is proportional to F by m. Acceleration is equal to F by m. From here, again what we can write, children? If we remove this proportionality, acceleration is equal to k into F by m. Okay, children? So here, from here, what will be F, children? F is equal to from here, F is equal to, send this sum here, children, m into a into k. See children, suppose there is 1 Newton of force acting on mass of 1 kg. It produced 1 meter per second acceleration, children. Acceleration is 1 meter per second square. Okay, due to application of 1 Newton of force on 1 kg mass, how much acceleration we got, children? 1. So from here, what will be k value, children? This constant k will be how much? K will be equals to 1. K is equal to 1. When we got, children? When unit force acting on a unit mass produce unit acceleration. Okay. So from here, what we can write, children? F is equal to k into ma. Okay. Since k value is 1. Since k value is 1. Finally, what we got, children? F is equal to m into a. Okay, children? So this is force equation. Okay, children? And one more point, children. The change in momentum of a body also proportional to force. Okay, children? According to Newton's second law, the rate of change of momentum of a body is directly proportional to change in force. What is another definition for actual definition, children? The rate of change of momentum of a body is directly proportional to force applied. Children, so that is the reason earlier, means in the previous case itself, I discussed about change in momentum. Okay, the change in momentum, children, that is initial momentum to the final momentum, that is created due to what? That is created due to force. Okay, So due to force, what will happen, children? There will be change in the momentum. Okay, due to force, what we get, children? There will be a change in momentum. That change in momentum is proportional to what? Force. Okay, so from this, what we can write, children? The change in momentum means Pf minus Pi. Pf minus Pi proportional to what, children? See, children, it is change of rate of change in the sense that particular quantity we need to divide with time. That is rate of change in the sense we will take with respect to time, children. With respect to time, there is change in momentum. That is proportional to what, children? Force. Okay, so that force is proportional to what? Rate of change. So that rate of change is proportional to is what, children? Sorry, force. So if you increase the force, if you give more force, then there will be a larger change in momentum, children. There will be a larger change in what? Momentum. Okay, children. So if we observe, F is equal to what? See, children, what we got now? F is equal to, F is proportional to Pf minus Pi by T. What is Pf, children? What is Pf? Final momentum. So m into final velocity minus what is Pi, children? Initial momentum means m into u, initial velocity, by time t. See, children, this proportionality I am removing and I am keeping some constant, and this k we can take m common, children. Okay, take m as common. So m into v minus u by t. Okay, children, m into v minus u by t. See, children, we know that v minus u by t is nothing but what? Acceleration. In kinematics, we have a formula. The change in velocity with time, that is nothing but what? Acceleration A. So, children, here what you can do? We can replace, okay, we can replace that v minus u by t with what, children? With acceleration A. Okay. So we got the equation, children, again. So F is equal to what we got? K into m into A. Children, again I am taking K value as 1. I explained the reason why I am taking K value as 1. For unit on a unit mass, we are applying unit force, it producing unit acceleration. So from this, what we got, children? Force F is equal to ma. Children, Newton did not said that, did not give direct formula that F is equal to ma. Newton's second law, it is not stating that F is equal to ma. Okay, we derived F is equal to ma. That is not Newton's law. Newton's law states that the rate of change of momentum is directly proportional to the force applied. Okay, from that relation, we derived what is formula for force. In order to explain this, in order to give idea about this, I explained about what is change in momentum, children, earlier. Okay, children, one more small relation. Once you send this t here, what will come? Once you send this t here, F into t is equal to what we got, children? Pf minus Pi. Understood, children? F into t is nothing but Pf minus Pi. So this is nothing but what, children? Earlier I said impulse. Impulse is equal to change in momentum. Impulse is equal to change in momentum. Okay, children, in order to get this relation earlier only I explained what is impulse. Okay, children, I hope you got clarity regarding what is Newton's second law, what is impulse and what is momentum. Further discussion will be done in the next lecture, children. Okay, until then, thank you and have a nice day.